Okay, welcome back. It's time to graph an exponential function. Now, just so you know, we are either going to have a graph that increases really fast, like that one, or we're going to have a graph that decreases really fast, like that one, or we're going to have a graph that starts tall but goes real slow, so it's kind of the opposite of what the one we just wrote. Or it starts real low and then it starts leveling off. Okay? Those are very different one from another. Ready? Let's take a look at problem 3. Graphing an exponential function. Here are your steps. Make a table, plug in some negatives and positives. Can you please plug in and 0, usually, and 0, so you have a nice idea of what this graph should look like. I'm going to point out some hints to you in a little bit, but for right now we're just going to learn how to make an XY chart. It's not nice and sweet like y equals mx plus b. We actually have to think this one through. So let's plug in -2, -1, 0, 1, and 2. And because I know what this graph looks like, let's plug in 3 to see what happens if we do plug in 3. So we're going to do 3 times the 2. And the exponent they want us to plug in is -2. Let's think this through, everybody. Remember what you learned in 7-1? That 2 to the -2 is really 1 over 2 squared. Remember how you have to put it under 1? And that's really just 3 times 1 over 4. So really that's just 3/4. I know that was a lot of writing, but again, you have to remember your stuff you learned in 7-1, otherwise this is really going to come back to bite you. Let's plug in -1. So that's 3 times 2 to the -1, which is really 3 times 1 over 2 to the +1, which is really just 3 over 2. We're going to keep moving on. Let's plug in 0. 3 times 2 to the 0. Well, you learned in 7-1 that's really just 3 times 1, because anything to the 0 power is a 1. And 3 times 1 is just 3. Let's plug in 1. 3 times 2 to the 1st power is really just 3 times 2, which is just 6. And good, we're getting away from the fractions, huh? Let's plug in 2 now. That's 3 times 2 squared, which is really just 3 times 4, which is really just 12. Last one. This is 3 times 2 to the 3rd power, which is really 3 times 8, which is 24. Yikes, right? That's very tall. That one might be pretty hard for us to graph, so I'm going to stop there. I think we're going to get a nice picture. Let's go left 2 because it's an x value. You can write it as a point if it helps you see it as a point. We're going to go left 2, up 3/4. Left 2, up 3/4 is right about there. And now what we're going to do is the next point. -1, 3 over 2. I hope you know 3 over 2 is like 1.5. So left 1, up 1.5. That's right there. Next one, 0, 3. Over 0, up 3. Look how it's getting bigger. And it's not getting bigger in a straight line. The next one is 1, 6. Over 1, up 6. If I go too fast, just pause the video to catch up. Now we can really see a curve starting to form. The next one is over 2, up 12. Oh, that one's going to be really tall, but that's okay. We can do it. There it is. Now, if I were to ask you which of these ones up here you think it is, I hope that you would notice it's this very leftmost one. It starts kind of low and it goes really tall, really fast. Let's connect this really tall, really fast side. If you can hear that, guys, don't worry, it's just a train. Remember, I live in Beaver Falls, so we have like trains and all kinds of stuff here. Okay? Now this side is going to come down but never cross the x-axis. I'll say it again, it's going to come down, but it will never cross the x-axis, so don't make it go through the x-axis. Let's try the goddess and see how you do with those. Alright, make an XY chart. I'm going to teach you some shortcuts in a little bit here, but first I just want you to get used to plugging in some values. Let's plug in -2, -1, 0, 1, 2, and we'll see if we want to plug in 3 or not. Okay, we might want to plug in 3 if we think we can fit it on the graph. So we do 0.5 times 3 to the -2 power, and if for all purposes right now, yes, you should be able to show me that, but I'm going to go ahead and just use my calculator. And that is going to be 1/18. That is super tiny, isn't it? 1/18. That is a very, very, very small number. Alright, let's try -1. You should be able to do this on your own, but if you need a calculator for assistance, just make sure you can get the right answer. So if you're using like your cell phone, make sure that your cell phone, you can do this, okay? Make sure you know how to type the things in. I know the feature how to turn it into a fraction. You should be able to do that anyway. You get 1/6 when you plug in a -1. Again, you should be able to do that. If you need some clarification, maybe I'll do that in the next couple of minutes. Oh, we can do 0 without the calculator. 0.5 times 3 to the 0 is really just 0.5 times 1. So it's really just 0.5 or 1/2. You guys know that, right? 0.5 or 1/2, that's the same thing. We can do 1 as well. We can do 0.5 times 3 to the first. Well, that's really 1/2 times 3, so that's really just 3/2. You should be able to do that math. I know I did it really fast, but you should be able to do that math. Even if you're getting decimals, you should be able to do this math. 0.5 times 3 squared. Well, that's like 0.5 or 1/2 times 9, and 1/2 times 9 is just 9/2. Alright, now what we're going to do is we're going to say, well, 9/2 is 4.5, right? Well, I can definitely fit that on my graph. I'm going to go up another one because I can get this to fit and it will give me a better picture. The more you pick, the better the picture you're going to get. So this is like 1/2 times 27, which is really just 27/2, which when we graph it, that's going to be about 13.5. Let's plot our points. -2 up 1/18 is like super small, isn't it? Way down there. -1, 1/6 is also incredibly small. 0, 1/2, well, that's over 0 up exactly 1/2. Over 1, do you know 3/2 is 1.5, so you go over 1 up 1.5. Over 2 up, do you know 9/2 is 4.5? So over 2 up 1, 2, 3, 4.5. And then the last one, over 3 up, now this one does get big, doesn't it? This one becomes 27/2, which is 13.5. So I'm going to have to count a little extra. Let's see. 13.5 would be right about here. I'm kind of eyeing it up. I know 13 went above my graph, so I want a little more. You can see that this is a growing, can't do two things at once, I had to draw my line. This is a growing exponential function. Again, it is going to continue, but it will never cross your x-axis. So we're learning how the shape of these things come to play out. Part B, let's go ahead and see what kind of answers we're going to get here. So we're going to keep the same x's. And if we need to plug anything extra in, we will, okay? Plugging in -2 is -0.5 times 3 to the -2. I'm going to use my cheat here. -0.5 times 3 to the negative 2 is negative 1 over 18. Well, that makes sense, right, guys? Because the negative out front's just going to change all of our signs. And since I hope you can kind of recognize that, it's going to be the exact same XY chart. The only thing this negative sign is going to do is change these. So this is going to be negative 1 over 6. You can just trust your math over here. Negative 1 over 2, negative 3 over 2. You can plug it all in again, but you really don't need to because that negative sign, all it's doing is making your answers negative. So let's throw 3 on there too. Okay, so I just took my y answers and I made them negative because of that negative sign out front. Let's plot these points and see how this graph is different. Left 2, down 1/18. Left 1, down 1/6. Over 0, down 1/2. Right 1, down 1.5. Maybe you're starting probably to see how this is coming together. Right 2, down 4.5. See how this is, it's just like the mirror image of the last one. And that's what negatives do. Negatives make mirror images. And then 3 is going to be down 13.5. Kind of eyeing that up, but it's right around there. Do you see how this graph just like, it goes down this time really fast. Instead of going up real fast, it goes down. And guess what? It's never going to cross the x-axis. It will always be on the negative side. You want to approach the x-axis as best you can. And you never want to, it never dips back down. It just gets infinitely closer to your x-axis. So graphing those, man, that's a handful, isn't it? Again, I'm going to give you some hints, but we'll do that towards the end, all right? Problem 4. Computer mapping software allows you to zoom in on an area in more detail. And you guys know that, right? Like you go to Google Maps and you hit the plus button and the computer goes whoosh and it gets bigger, and then you hit plus and it goes whoosh and it gets bigger. That's the idea. It actually really does use a function somewhat like this. It starts at 100%, and you see that 25% there? What that does is it allows you to zoom on in something like a quarter closer, okay? And it represents the percent of the original area of the map, and it shows it after zooming in X amount of time. So it's getting closer and closer and closer and closer, okay? What we're going to do is we're just going to get some X, Y points here, and we're going to graph this puppy. Again, if you need to, this is kind of like the idea. Like, look, Miami's way, way, way far away. And then we zoom in and it gets closer. And then we zoom in and it gets even closer. Just like it would on Google, right? If you hit that little plus sign. Okay. Now, we can graph some negatives. All right? But we don't have to. Let's just start. Let's start graphing some negatives and then talk about what that means. Let's do negative 2, negative 1, 0, 1, and 2 and plug some stuff in. Okay, negative 2 is going to be 100 times 0.25 to the negative 2 power. This might actually surprise you about the answer that we get. 100 times 0.25 to the negative 2 power. Whoa, look at that obnoxious number. 1600. What that would be doing is unzooming in, because it's negative. I'll say that again. It's unzooming in. In other words, it's zooming out. And it's getting 1600 times as big. Okay, the area. Isn't that kind of crazy? It's kind of like a percent. It's actually like 16 times as big. That's what that means, 1600. Now let's plug in negative 1. Let's say you only click the zoom out button once. That's what that would mean. You click the zoom out button once. Put it into your calculator. Whoa, 400. What that means is that if you only click once, it's only 400 times as large as it was. And that's if you zoom out. But now let's say you don't click at all. Let's say you do 100 times 0.250, 0 being how many times you either zoom in or zoom out. Well, anything with a 0 is 1, so that's just going to be 100. That should make sense. If you don't do anything, it should be 100% of what you used to see. I'll say it one more time. If you don't do anything, it should be 100% of what you saw. Now let's say you actually do start to click zoom in. You're going to do 0.25 to the first power. Plug it in, and change that to a positive, and you get 25. Now what does that mean in terms of this problem? It means that by clicking zoom in once, you have taken your original picture down to 25% of what your picture used to be. Okay? It's like you're seeing just a quarter of it now. Now let's say you click zoom in again, so you have 0.25 to the 2 power. You're zooming in another extra time. You are only going to see 6.25 of the original 100 area. Okay, so yeah, the more you zoom in, look how fast this thing is going down. Now we would never ever graph these two numbers because they're so big. In fact, we're going to do 0, 100, but we're going to count by tens, okay? So we're going to go over 0, up tens. You might want to write that so when you study you understand y-axis by 10. Okay? Over 0, up 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There's your first dot, and it's at 100 if you want to write it down. So that's like your original. And then you zoom in once, so you go over 1, up 25. Over 1's up 25. Remember, if this is 20, going up an extra one would be going up 25. So let's see, if this is 20, that's going to be 25. Yeah, I had it. And then if you click it twice, 1, 2 over, it's going to be just below 10. It's going to be at 6.25. So wow, look at that curve. You can see this one is getting smaller. Now it will approach the x-axis, but guess what? It will never stop approaching the x-axis, and at the same time, it will never cross. And it is going to get super tall. The more negative you go, that's zooming out. So the more you zoom out, the bigger your picture is going to get. So that's what that means. The more you zoom out, which is negative, the bigger your picture is going to get. The more you zoom in, positive, the smaller your picture is going to get. All right, we'll try to get these notes done in the next set of videos.